This video is going to base on a domain of any function or almost any function that you can think of. So the idea here is that we are going to discuss a domain of a function of a polynomial. So if you had the idea of a polynomial, right? So and I'll explain everything in just a few seconds. So polynomial, and then you have what rational function, and then as well as let's say radical, right? So radical set, right? So we are going to talk about the domains of these three functions in this video. So make sure that you stay here to the end of this video if you want to know more of these things. Now the idea of a domain is that, so let's say as you want to join any group, right? So what I normally do here is that you want to join any WhatsApp group. Is that okay? So an WhatsApp group here. So you want to join that group. Now the group has some certain conditions, right? So the condition is that you have to make sure that you produce some values. Is that okay? Maybe let's say you have to bring another person to join that group, right? So let's say you are here right now, and then you want to join this group. Now the law or the rules of this group is that once you join, you have to make sure that you get in another person. Is that okay? So you have to produce another what being here. All right, so you have to produce another species of what your kind. That is the key word there. At least just one person, right? At least one person here. Okay, so now the WhatsApp group here will be our function, right? So the X here, you want to join that group will be the X here. So we are calling it to a domain. Once this is a domain, it means that we are going to produce what another person, or you are going to invite another person here. So that is the word here. So let's say you want to invite, you must, right? So the word here, you must. It's very, very important. So you must invite another person to join what the group. Is that okay? So once you cannot invite anybody to join that group, you are not what you cannot qualify to be the member of this WhatsApp group. Now, if once you are able to invite another person to join the group, then we say that you are the domains of this function. So if you call the WhatsApp group here a function, all right? So you call the WhatsApp group here a function, then what it means is that you are what the domain of what this function, but since the condition is what satisfied, because you can bring another person to join that group. Now the first one, as I said earlier on, is that is a polynomial function. So what we call a polynomial function here is, this is a typical example. There's a very simple scenario of what a polynomial function, right? So this thing can be anything you can think of, anything that goes straight like this, right? So what I mean by the straight is not being divided into or by any number, or is not under any radical sign, or and so on and so forth, right? This is just a straightforward answer. Okay, now if this is another polynomial that you can take, that you want to find a domain of this function, right? So you want to find a domain of this function. This is what we are calling the function. So in our scenario, this thing can be the WhatsApp group. Is that okay? This thing can be the WhatsApp group here, right? So this thing can be what the WhatsApp group. So this is the condition that you have to obey. So what is the condition? The condition is that once you want to join this group, you have to be ready to invite another person to join the DAO group, right? So let's say the X here is you. So the X here is you, right? So the X here is you. So whatever you want to join, then we are going to replace you by this X and see what we can bring at the end of or by the end of the day. Is that okay? So that is the condition. So once anything that you bring here, we are going to replace that by what? The X here to determine. So let's say in terms of what a number, so mathematically, let's say X here, you are what? You are just what 2. So meaning that X is equal to 2. So we are going to replace this 2 here by what the X in our row here. So we have the F of what? F of 2, that is the function. So F of the 2, whatever you say the X, you replace that by 2. So F of 2, that's going to be what? The 2 squared, right? So 2 exponent 2, then plus 1, that should be equal to 4 plus 1, and then the answer here is 5, right? So it means that you can give us another 5%. Just say by an assumption, you can give us another 5% to join that group. Is that okay? So once you're able to do this, then you say that you are the domain of this function. Now this is just for just one person. What will happen if you have a millions of people want to join this group? Is that okay? So how can you determine that? So mathematically we say that if it is a polynomial function, the domain of what any polynomial function is the set of all real numbers. So all real numbers here is the domain. So any number that you can think of. The idea is that if you put any number in place of this x here, right, I'm going to grab something out, right? Anything. It can be a fraction. It can be that can be a natural number, say any integers, any number that you can think of. It can be negative. It can be positive. Anything that if you are replaced by the x here, I'll get something out. Is that okay? That is why you say that the domain here, the domain of what f. So the f here stands for what? This function, right? So the domain of the f here is what or what all real numbers, right? All real numbers. Okay, so that is what we call the domain of this function. So particularly for the polynomial, the domain of that function is the set of what all real numbers. Okay. Now what about what the rational? So talking about the domain of the rational, let's have a look at that in the next section. We first of all have to understand what we call what a rational, or maybe sometimes who do we call a rational. So this is just the function note, one of the function notation here. Now this is what we call a rational. A rational because it's always you have something on top and then there's another thing at the down here, right? So that is the key word of the word rational. So if you say that something is a rational in mathematics, maybe this is not being a rational decision taking or something of that nature, but mathematically, if you say that something is a rational, it's always have something on top and then there's another thing at the down here. Right, so that's just the simple. Always there's one guy at the top here, there's another person at the down here. So that is what we call what a rational. So we don't care whoever will be at the top or whoever will be at the down. All that we know is that there's always one thing at the top and there's another thing. So maybe you can think of something like this. This is just a rational number, but of course this is not a rational topic. But here we are solely talking about the domain of what a rational function. So if you want to know more of this content, make sure that you subscribe to the channel and comment down below. Give us a thumbs up if you are getting some value from this video. Okay, now as at this point, since we want to find a domain, now that we've got a clear understanding of what a domain is, the point here is that how do you find the domain of this function? So we want to find the values of this x here. Well, whatever you replace the x by, then you must get a result out. Is that okay? That is the most important. You must always have something out anytime you replace this x. Right, that is the key word. If you I replace this x by any number, then I'm not getting any number, any results out. Then it means that whatever I put here is not what a domain here. Is that okay? That is very useful. So how do you do that? The key here is that you have to equate the down here to 0. So s plus 1 equal to 0. So why are we doing this? We are doing this thing because if you have a number, let's say any number that you can think of, that should be 3 divided by 0. This is not possible in mathematics, right? You cannot divide 3 by 0, right? Let's say you have a $3, any currency that you can think of. So that currency, you want to share that among nobody, right? So this 0 just stand for what? Nobody here. So nobody is not possible. So if you want to divide any amount that you have by some people, you must always have some people here for you to share. But if there's nobody, this is not possible even in the real life. So in mathematics, you cannot divide anything by 0. Now, so to find the domain of a rational function is that you have to make sure that the down here equal to 0. The reason is that we want to find that person will make the down here equal to 0. That is why you always equate the down here to equal to 0. So if you solve this one, you are going to have s equal to -1, right? So subtract -1 from both sides of the equation. So you are having s is equal to 0. -1. So since s is equal to 0, this -1 will make the down here equal to 0, right? So the domain of the function here is that all values of x, right? So the domain here is all values of all values of x except, right? So except x is equal to -1, except this guy is equal to -1. The reason is that once you replace the x by -1 into this function, meaning that the down here is going to be 0. So let's have a look at that. So wherever you see the x, you replace negative. So -1 divided by -1 plus 1, that should be equal to -1 divided by 0, right? Which is not possible in mathematics, right? So we say that the domain of this function is that all values of x, but in the real numbers, right, except that x is equal to -1. Is that okay? So this is very, very simple to write. So the key here is that you just have to know whoever is at it down here. Sometimes you can have a quadratic, right? So it can be, let's say, x squared plus, or let's say 2s and then -1. So depending on the function that you have at it down here, right, that is how you have to solve. So you must practice some. If you want to know how to go about different functions that are down here, join the subscribe, maybe comment down below, right? Comment in the comment section below. Subscribe to the channel so that you can see more content. Like, let's hear from you in the comment section which function that you cannot solve if you come across anything at the down here, right? So this is just a quadratic. We solve this thing by what? A quadratic method. Now, final part of this video is that how to deal with a radical. So if you want to find the domain of what, any radical, right? So any radical. So let's have a look at that. So if you don't know what we call a radical or a set function here, just learn this thing by a picture, right? So the image here is that, let's say you have some people under a roof here, right? So this thing can be in a room. So this is what we are calling the room here. This symbol here is what we call the radical symbol. So you can see that there are some numbers under this radical. So this is what we call a very simple radical function, right? So we don't care whoever is at the down here. So our aim here is to determine what the domain of any radical function that you can think of. So the way of solving this thing is that you see, bring this thing down to the point whereby you have anything a negative one, right? So let's say -1. This thing doesn't exist in mathematics, right? Maybe at your level here, this is not possible. It's okay. So let's assume that square root of a negative number is not possible in let's say a high school, right? So you may try this thing. If you're on a calculator, you are going to have an error, right? So that is what the key here. Now, so the point here is that we don't want to have a negative number under what this radical. Is that okay? So we don't want to have what a negative now. So how do you solve this? So there are two ways of solving this thing here. The first one is that you may equate this one to less than what, less than minus s minus 1, that is less than 0. So anything that is less than 0, you agree that that is what, negative. So if you are less than 0, you are going to the left hand side of the 0. So let's say 0 is here. So if 0 is here, less than 0, so it means that anybody that is here, that should be -1, -2, and so on and so forth. Right? So if you are less than 0, meaning that you are going to be on -1. So once we have that number that which is less than 0, then it means that that number is our greatest enemy here. So once we plug that in here, we are going to have a negative, which in the case we don't want to do that. So if you solve this thing, you should have your x that should be less than 1. So here, this is how you write the domain of this function. So how to write this thing is that you write that the domain of the function. So you just need to name the function. So the function is h. So the domain of what? The domain of h, right? So the function h, sorry, this is h, right? So according to this one, this is h. So the domain of h is of all values of x, right? In what, the real numbers, right? So all values of x, whichever way you want to write it, that is accepted. So here, except what, except uh, x is less than 1, right? So less than 1. So any value that is less than 1 here will make this down here goes to negative. So that will be our greatest enemy. Is that okay? So this is how you should write the domain of this particular function. Or maybe in some cases you can say that you can equate this thing to be what, greater than or equal to 0. So here can be what, x minus 1 greater than what, equal to 0. Is that okay? So any value that is greater than or equal to 0, so we are going to have a positive, right? So maybe 0 is accepted, or anything. If the number here is equal to 0, we are going to have an answer. So square root of 0 is 0, right? And square root of any positive number will also give you what, another number, right? So except that this is what, a negative. Is that okay? So here, if you solve this, you are going to have s is greater than or equal to 1, right? So equal to 1, greater than or equal to 0. So you can see that here is the values of the domain of this function is what, all values of x that is greater than or equal to 1. Is that okay? So there are two ways of writing this. So you can say that greater than or equal to 0, or maybe less than or equal to, depending on the function that you have. If you get some values from this video, once again, don't forget to give us a thumbs up, subscribe to the channel, comment down below for any function that you want to see relating to what, these three functions.